Yes, Baptist.
Yes.
Can we continue? Yes, Stephen. 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 Stephen.
Yes, teacher.
Are we together, Stephen? Yes, are we together?
Yes, teacher.
Okay. So let's continue. Let's continue. So now, when this one and this one cancel out, so when I bring this one this side, because this one is negative, so I will have 2 m1 u1 m2 v2 equals to m2 squared v2 squared plus m1 m2 v2 squared. Remember, I want to make v what? I want to make v2 the subject. I want to make v2 the subject. I want to make v2 the subject. So what should we do from there as well? Now, what should we do from there?
It's going to be 2m1 u1 m2 v2 equals to m2 v2 squared into brackets m2 plus m1.
Yes?
There's going to be 2m1 u1 m2 v2 equals to m2 v2 squared into brackets m2 plus m1.
Members, are you following Stephen? Are you following what Stephen is saying? Sandra?
Yes, teacher.
Stephen, I beg your pardon. I beg your pardon. It's going to be?
It's going to be 2m1 u1 m2
2m1 u1
m2 v2 equals to m2 v2 squared
m2
v2 squared into brackets m2 plus m1.
m2 plus m1. Perfect. So you find that this v2 will affect this v2, right? Not so. Here we have v2. Here also we have v2, which means this v2 will affect this one here.
Yes.
So let me just say, dividing all through by m2 v2. m2 v2. I think that. So this will cancel with that. Then this will go away with this. Then this will affect this one. Then it will remain with only 1 here. So we shall have m2 m1 u1. Okay? I think that equals to, now I remain with only v2 because this v2 has affected this v2 squared here. So into m1 plus m what? Plus m2. So I want v2. So I just divide. So therefore, our v2 will be equal to 2m1 u1 over what? m1 plus m what? Plus m2. Have you seen that, Stephen? Sandra, have you seen that?
Yes.
Have you seen that?
Yes.
Yes, teacher.
Perfect. That's why that other one was not coming, because we made that mistake in LOCM. Now, that was between P and Q. That was between P and Q. Then they have said again Q. Q makes a what? A perfectly inelastic collision with R. So for this case, I'm not going to call it V2. I'm going to call it V3. The final velocity of what? Of that. So which means, so for inelastic collision, what? Collision. Between what? Between Q and what? Q and what?
Yes, sir.
Q and R. It's very important to have a sketch there. So this is now Q, which is M2. So what will be the initial velocity? So this is it. Will be what?
V squared for Q.
Will be V2, not so?
Yes.
will be V2. Will be V what? V2. Okay?
V2.
Then R is here. M what? M3. And is moving with, let's say U3. U what? U3. So after collision, they will stick together. This is M2. Then M what? M3. Then they will move now with a common velocity V what? They will move now with a common velocity V3. I think that. I don't want you to cram what is there in a question. I don't want to cram that. That's why I'm using different letters so that we can see it clearly.
Yeah.
Okay? Okay? So this is before collision. And then this is what? After collision. Remember all the 3 balls, they were initially at what? They were initially at rest, which means U3 is what? 0 meters per second. So which means now we shall have M2. I'm using now the principle of conservation of linear momentum times V2 plus M3 U3 equals to so we shall have M2 plus M3 V what? V3. Members, are you seeing that? So U3 is 0, which means now we shall have M2 V2 equals to M2 plus M3 V3. So now they want us to find V3. So can we find V3 from here? Can we find V3?
I'll see this one.
So it implies now V3 will be equals to M2 over what?
Yes, teacher.
Over what? Over M2 plus M what?
So we are students in that class.
Over M3, no sir?
This is math. I don't have a senior 5 doing math.
I think that
This is just
members.
5. Are you sure this is just 5 math?
I don't know.
M1
Members.
Because you know some of them are
Yes, teacher.
Okay, let me first finish.
Please, there's this person called personal.
Excuse me.
This person called personal, please. There's a lot of noise in your
Excuse
back.
me, sir.
Yes? Yes, Apire?
Sir, I'm having problem with network here. May you just go over it as you talk?
We are saying, because they're saying that we have 3 balls here. At first, we considered P and Q, and we got V2, not so? We got V what? V2. Then they're saying that Q and R add what? Inelastic collision, perfectly inelastic collision. And we know what happens during inelastic collision. The 2 bodies will stick together after collision. So which means the initial velocity, V2 become initial velocity for Q. Then M3 is U3. So after collision, they will stick together. We know that they will stick together. And then they will move with a common velocity now, V what? V3. Why are we saying it V3? Because this one is V2. We can't make it again V2. So this one should be V3, the final velocity of the 2 bodies. Okay? Now using the law of conservation of linear momentum, which is this, for perfectly inelastic collision. M2 V2 plus M2 3. But remember, they said that all the 3 balls, initially they were at rest, which means the initial velocity of ball Q will be what? Will be 0. So which means if you substitute 0 there, we remain with only what? M2 V2 equals to M2 plus M3 times V what? V3. And they want us to find the velocity of this one here. If you look at the question, they're saying that show that R move with velocity this one, which means is the velocity after collision. Remember, initially it was at rest, which means they want us to find V what? V3. Are you seeing that, members? Are you seeing that?
Yes.
So now so we say that if you make V3 the subject from here, if you make V3 the subject, it will give us this. It will give us what? That. But when you look at our answer here, they want us to show we don't have V2. What should happen to V2? You should remember that, but V2, we got what? V2 was 2 M1 U1 over what? Over M1 plus M plus M2. So substitute for M2 here. If you substitute for that in that formula, what do you get? What do you get?
V2.
You find out V3. V3 is going to be equals to M what? M2 into 2 M1 U1 over M1 plus M2. Not so. Everything is over M1 plus M2. Right? Right?
Yes.
Yes. So let's take this one inside now. Let's take this one inside. So down here is supposed to be M2 plus M3, sorry. Because of this. So V3 will be equals to, when you might take this one inside here, we shall have 2 M1, M2, U1, right? Over,
yes,
over M1 plus M2. We are dividing it. Let me put it like that so that you can see. Divided by M2 plus M what? M what? M3. So what will happen here? What will happen? We get the reciprocal. We get the reciprocal, right? So therefore, V3 will be equals to 2 M1, M2, U1 over into M1 plus M2 into M2 plus M3. Is that what they wanted? Is that what they wanted, members?
yes,
Yes.
Yes, this is the one. Have you seen that?
yes.
Yes. So that is all about using. So just a matter of playing around with the formula. Just a matter of playing around with the formula. Okay.
So now you,
Yes.
sir,
Yes.
you now leave now about those the issue of P.
The issue of what?
P from the beginning.
So P, we have used
Because
P.
they didn't ask.
Yes, they didn't ask for P. Okay. They wanted us only to find out. We are using the consistent here. There are two types of collision. At first was between P and Q. And between P and Q was elastic. Then between Q and R was inelastic. But according to this question, they want us to find what? Show that R move with velocity what? This one. They may also ask you to show that Q move with velocity this one. Because they were moving with the common velocity. Okay? They are moving what? So this is the final velocity. The final what? The final what? The final velocity for ball Q and what? For ball Q and what?
R.
And R. After what? After what? After collision. Are you together, members? Are we together?
Yes.
Yes. So I think with all this discussion we have made, you cannot fail to answer any of these questions down here. Can you fail again? Can you fail to answer any question that comes down here again, members? Okay. So let's just do one question. Let's do one question. Let's do one question now. This one where the answers are there, that one you already have the answers. There's no need for discussing them again. So let's go to revision questions. Let's go to revision questions. Exercise 13. Exercise what? 13. Stephen, Abiona. Sandra?
Yes.
I'm leaving those one with answers because those one you already have the books. You can go through them. Okay? Okay?
Yes.
Yes. So let's do the exercise here. Let's do 1, 2 question from the exercise. Then where time will get up, that's where now will be your question now. Which one should we start with? Let's start with question number 1. Let's start with question number 1. What are they saying in number 1? They're saying a 2 kilogram object moving with a velocity 8 meters per second collide with a 3 kilograms object moving with a velocity that in the same direction. in the same direction. If the collision is perfectly inelastic, calculate the decrease in the kinetic energy. So which means they're telling to find energy what? Loss. Energy what? Kinetic energy loss. But for you to find that answer, to find the kinetic energy loss, you must start working from the first principle members. You must start working from the first principles. So we have two bodies here, moving in the same direction with a velocity of 8 meters per second and 6 meters per second, and they're moving in the same direction. They're moving in the same direction. So you start saying for perfectly or for completely, depending how the question I've said, perfectly in elastic collision. Okay, so our M1 will be the 2 kilogram mass. U1 will be 8 meters per second. It's very important to separate, to define them like that when they are not defined in the question, so that the examiner, when the examiner is marking, shows that hey, M1 is already 2, U1 is 8. So which means definitely our U2 will be 3 kilograms. Then our U2 will be 6 meters per second. Then after that, go ahead and sketch. Go ahead and sketch how the two bodies will move after and before collision. So this is it, our M1 moving with U1. This is it, our M2 moving with the U2. That is it, before collision. I said separate them with this line. So since they were perfectly inelastic, so they will stick together and move with a common velocity V. So this is our M1, this is M2. So before collision, before and then after collision. So then you come and say, using the law of conservation, of linear momentum. This one is very important because you are giving the context of your work. You are showing the examiner that you know what you are talking about. You know what you are talking about. So since then you come and said for completely inelastic collision, because you must be careful with that. So which means M1 U1 plus M2 U2 equals to M1 plus M2 V. So what are we looking for? What are we looking for here, members? The question is very direct. The question is asking for the decrease in the kinetic energy. But we cannot find the decrease in kinetic energy without finding the final velocity, because kinetic energy depends on the velocity of the body. So we need to find the kinetic energy, the speed of the body after collision, which is V. That's why we are still using this one. So after finding the final velocity V, then we go ahead and using the conservation of energy. But remember, for inelastic collision, kinetic energy is not conserved. Then you must work them separately. So you find kinetic energy before collision, then you find kinetic energy after collision. Is that clear, members? Is that clear, my dear students? Is that clear?
Yes, sir.
Go ahead and substitute. So when you are substituting, put them in brackets to avoid making errors in integers, to avoid making errors with integers. So since they have told us they are moving in the same direction, which means we take all of them to be positive, because they are all moving in the same direction. But if they were moving in opposite direction, we shall take one to be negative. Okay? So since this one, they are moving in the same direction, all of them will be positive. So we shall have 2 times 8 plus, open a bracket, 3 times 6 equals to 2 plus 3 V. So this one will be 16 plus 18 equals to 5 V. What is 16 plus 18? What do we get? We get 30?
34.
34. So 34 is equals to 5V. Divide all through by 5. Divide all through by 5. So it implies now our V will be equals to, so what is 34? 34 divided by 5. We get 6.8 meters per second. That's not our final answer. So we have got the velocity now. So we go to kinetic energy now. Kinetic energy is not conserved. So kinetic energy before what? before collision, which we know is going to be given by I have m1 u1 squared plus I have m2 u2 squared. So what shall we get? So we shall have I have time 2 time 8 squared plus I have times 3 into 6 squared. So can you give me the final answer, please? Just give me the final answer, please. Give me the final answer. Give me the final answer. So this one will be I have times 2 times 64 plus I have times 3 times 36. So what is the final answer, please? Members, what is the final answer? So kinetic energy, you can call it initial, will be, what will you get? What shall we get? What shall we get? These two will cancel out these 2 by 2 there, we shall have 18. So we shall have 64, 18 times 3, which will give us 54 plus 64. What do you have? 100 and? Members, what do you have? 100 and what? 18, right? Sandra?
Yes.
What do you have?
118.
What is the unit? Joules. That is before. So go ahead and find kinetic energy after collision. Kinetic energy after collision, which will be kinetic energy final. Kinetic energy final, which is going to be given a half into m1 plus m2 v squared. V squared. We shall have a half time 2 plus 3 times our final velocity, which will just got 6.8, but squared. So this will be a half times 5 times 6.8 squared. So our kinetic energy final will be 6.8 squared. We get that
115.6. 115.6.
115.6. What?
6
150 joules. So they want us to find the decrease in the kinetic energy, which is the same as the energy loss, which is the same as kinetic energy loss in kinetic energy. Loss in kinetic what? Energy. Which is going to be given. Now you just look at the value which is big. Which one is big?
118.
So we shall have 118 minus 100 what? 15.6 joules. So what is the difference there? What do you get? 2.4.
2.4.
2.4. 2.4. Yes. And J, this J must be capital because it's the name of a person, please. It's the name of a, must be capital. Okay? Must be capital J. Okay?
Yes.
Members, have you seen that?
Yes.
Members?
Yes, teacher.
Yes.
Which other question should we do? We have done number 1 because I want you to remain with 2 questions. Which one should we do again? We do number 2. Members, should we do
Let's do number 3.
Number 3, eh?
Number 2.
Okay, Sandra is saying we do number 3. Now, which one is which?
I think number 2 may be it's the same.
Yes, number 2 is the same. Because the only difference here, they're saying calculate the percentage loss in the kinetic energy. So the percentage loss you can calculate. So to get the percentage loss, you first get the what? What will be the percentage loss?
Loss in the kinetic energy.
Yes. You just do that, okay? Let's do number.
Then after divide by 100. After getting the loss, do you divide by 100?
No. Percentage loss in kinetic energy will be the loss in the kinetic energy divided by the kinetic energy before collision. Kinetic energy before collision. Okay? Times 100. Okay?
Okay. Yes.
Yes. So percentage loss in kinetic energy, percentage loss in kinetic energy will be equals to loss in kinetic energy divided by kinetic energy before collision. Kinetic energy before what? Collision.
Illusion.
Times what? Times what?
100.
Times 100%. So let's go to question number 3. So which means question 2 is your exercise. Question 2 is what?
Exercise.
2 and 4. 2 and 4 will be your exercise. 2 and 4 will be your exercise. So let's go to question number 3. What are they saying in question number 3? They're saying a particle of mass, 2 kilograms moving with a speed of, so let's say our M1 is equals to, is 2 kilograms, and moving with a speed U1 is 10 meters per second, collides with a stationary particle of mass, so M2 is equals to 7 kilograms. So since it's stationary, which means U2 is what? 0 meters per second. Immediately after the impact, the particles move with the same speed, but in opposite direction. Immediately. After collision, after impact, the two particles move with the same velocity, but in opposite direction. Members?
Yes.
What does that one mean? I'm sorry, our network is not stable. Network is not stable. Yes, Stephen.
Yes, teacher.
What does it mean now? What does it mean? Which type of collision is that? Which type of collision is that? Is it elastic or inelastic?
Elastic collision.
Is what?
Elastic.
Elastic? Yeah, they're saying they move with the same velocities, but in opposite direction.
I thought number 2.
We are doing number 3. We are on question number 3. Immediately after impact, the particles move with the same velocity, but in opposite direction. Okay, let's go ahead and do that. Go ahead and sketch that. So this is our M1, this is our U1, okay? This is our U2, this is our M2. So which means if they are moving together with the same velocity, which type of collision is that? That one is inelastic, not so? But in opposite direction. Which means opposite direction, which now, because initially we are making, which means now this time they will move like that. I think that members. I think that.
Yes, teacher.
Yes. So this is before impact. Then this is after impact. So they want the loss in the kinetic energy. And we say that because that's even you can't just because they're asking the loss in kinetic energy, because we say kinetic energy is only lost in what? Kinetic energy is lost in what? In elastic what? In what? In elastic collision. Okay? Because for elastic collision, kinetic energy is conserved. Kinetic energy is conserved. So let's go ahead and find that. So you know what to do. So let's find this velocity now. So start have m1 u1 plus m2 v2. I mean u2. Sorry, equals to m1 plus m2 but v. Okay. So we shall have 2 times 10 plus into 7 times 0 equals to 2 plus 7 v. So we shall have 20 plus 0 equals to 9 v. So 20 is equals to 9 v, divide all through by 9, divide all through by 9. So we find our v. What is our v, members? What will be our v? 20 divided by 9. We shall get 2.2 meters per what? Meters per second. 2.2 recurring, not so? Meters per second. So that's the final velocity. But they want us to find the momentum. So since they are moving in opposite directions, you must attach a negative there, members. You must attach a what? So therefore, the final velocity will be negative 2.22 meters per what? Per second. Why are we putting the negative? Because it's moving in opposite direction. It's moving in opposite direction. Okay? Yes. So let's go ahead and find the energy now. So kinetic energy before collision. Kinetic energy before collision, which will be I have m1 u1 squared plus I have m2 u2 squared. So we shall have I have time m1 is what? M1 is 2 time 10 squared plus I have time 7 times 0 squared. So you find out shall remain with I have times 2 times 100 plus I have times 7 times 0. Everything here becomes 0. So this and this will disappear. So kinetic energy, initial kinetic energy becomes what? Is 100 what? Is 100 what? Joules. Then kinetic energy after collision. Kinetic energy after collision. Kinetic energy after collision, which will be I have into m1 plus m2 v squared. V squared. So we find that now our kinetic energy will be I have into 2 plus 7 into negative 2.22 squared. So which has no effect because we are squaring a negative. So I have times 9 into 2.22 squared. Because we are squaring a negative, the negative will still become a positive. So 2.22 close squared times 9 divided by 2. What do you get? What do you get? Members, what do you get? Members, what do you get? Yes? Sandra? Sandra, what do you get? What do you get?
I don't have a calculator with me.
Sandra, be serious. Okay, so you will get, let me work it out, 2.22 squared times 9 divided by 2. We shall get 22.1778 joules. So this is kinetic, and this is the final kinetic energy. That's the final kinetic energy. So since they're asking for the energy, kinetic energy lost during collision, so kinetic loss in kinetic energy will be 100 minus 22.1778 joules. So which will give us 100 minus 22.1778, which is supposed to be 70 what? Supposed to be 77.8222 joules. That's the answer, please. Not 28. Not 28, please. Not 28. Okay?
Yes.
Are you together, members?
Yes.
Yes. So we have only 3 minutes remaining. So your exercise is question 2 and question 4. Question 2 and question 4. That's your exercise. So the next time we meet, which is on Saturday, we shall look at what we call ballistic pendulum, which is still under collision. It's still under collision, members. Don't worry about that. It's still under collision. And that one we shall now summarize. We shall summarize momentum. Then after that, we shall go to friction, I think. I think our next topic is friction. Yes. So on Saturday, we shall finish ballistic pendulum. After that, we shall discuss, and then we summarize that. Are we together, members?
Yes.
How was the lesson? We have understood, right?
Good.
We have understood,
Yes.
right?
Yes.
Okay. So, as usual, do the exercise and submit on my WhatsApp. As usual, do the exercise and submit on my WhatsApp. Okay?
Yes.
Yes.
Okay, members, have a blessed day.
Likewise.
I will wait to see your work. I know people will get answers, but I want to see how your presentation work is very important. Okay? I think you must be learning from how I'm presenting my work. Very organized. You must be very, very organized. That's what we request from science students. Science student, you must be organized and smart, both physically and in the brain. Okay? Are you together, Stephen? Stephen?
Yes, teacher.
Yes, I know you have already started working on it. Have you finished copying the question? Have you finished copying the question? If you don't have the book, please
Yes,
copy.
I've finished.
You're finished. Okay, bye.
Bye.